Hello everyone. In this video, we are going to see about an introduction to the theory of automata. Now, let us first see what is meant by the theory of automata. Theory of automata is nothing but it is a branch of computer science and mathematics. Most specifically, it is a theoretical branch of computer science and mathematics. It is a study of abstract machines and the computation problems that can be solved using these abstract machines. So, this subject, that is the theory of automata, will help us to study abstract machines and the problems that you can solve using these abstract machines. And to extend it further, what is meant by this abstract machine? This abstract machine is otherwise called as the automata. When you have a number of abstract machines, you call it as automata. When it is a single abstract machine, you call it as an automaton. Now, what is the main motivation behind this theory of automata? The main motivation behind this theory of automata is to develop methods to describe and analyze the dynamic behavior of discrete systems. See, when we are designing products, when we want to come up with new designs, we need to see how the system will behave. So these abstract machines or these automata will help us to develop methods with which we can design new machines and products. So that is the main motivation behind the theory of automata. And what will this automata do? This automata will take some string as input, and this input will go through some set of states where the number of states is finite, and finally it enters the final state. If the input string is able to enter the final state, then we say that the string is accepted by the automata, or the string belongs to the automata. So that is what this automata will do. And then how does it go about? It makes use of state transition diagrams with which we can try to build this machine. Normally, we will represent state with the help of circles, and transitions are represented by using arrows. So let's again go through what is this theory of automata. So as told earlier, theory of automata is a theoretical branch of computer science and mathematics with which you can study abstract machines and the problems that you can solve using these machines. An abstract machine is called as an automaton, and abstract machines are called as automata. The main motivation behind this theory of automata is to develop methods to describe and analyze the dynamic behavior of discrete systems. And how is this automata going to function? It will take some string as input, and this input will go through a finite set of states, and finally it may enter the final state. And how are we going to represent these automata? We are going to represent them with the help of states and transitions. States will be represented with the help of circles, and transitions will be represented with the help of arrows. So this is the basis of theory of automata. Now let's look into some basic terminologies that we will use when we are going to develop this automata. So the first basic terminology that we're going to see is, what are symbols? The definition of a symbol is, it is an entity or individual object which can be any letter, alphabet, or any picture. So symbol. So as all of us know what a symbol is, any entity can be considered as a symbol. For example, the letter A is a symbol. The letter B is a symbol. The symbol comma, okay, it can be taken as a symbol. The number 2 is a symbol. This particular ampersand is a symbol. So these are what is meant by symbol. So let's see some example. 1AB hash. These are examples of symbol. Now coming to the next basic terminology, which is meant by an alphabet. Now what is an alphabet? Alphabet is nothing but it is a finite set of symbols. We know what a symbol is, right? We know what a symbol is. Finite set of symbols will constitute the alphabet, and we represent alphabet using the symbol sigma. So let's see a few examples of our alphabets. See, when you say sigma equal to a comma b, that means the finite set of symbols in this alphabet is a, small letter a and small letter b. When we say sigma is equal to a comma b comma c comma d, then our alphabet consists of the finite set of symbols capital A, B, C and D. So these are some of the examples of alphabets. Now let's go on to the third basic terminology, which is meant by a string. What is a string? String is nothing but a finite collection of symbols. From where do we get these symbols? We get it from the alphabet. And we denote a symbol using the letter small w. So, for example, just take, if sigma is equal to a comma b, then we can form various strings from this particular alphabet. So it can be A, AA, AB, BA, triple A, double B. So this can go on. So these are all the possible strings that we can generate from the alphabet sigma equal to A comma B. Right? So this is what is meant by a string. String is nothing but a finite collection of symbols that we can derive from the alphabet. When we have a string with zero occurrences of symbols, then the string is called as an empty string and it is represented by epsilon. Okay, and the number of symbols in the string will contribute towards the length of the string, which is denoted in this way. So this is the third basic terminology. Now we move on to the fourth terminology, which is language. What is meant by a language? A language is a collection of appropriate strings. So a number of strings put together will form a language. When we say appropriate strings, strings which are similar to each other. Now, how are these strings going to be formed? These strings are going to be formed over the alphabet. And when we form the strings over the alphabet, then you call it as a language, and we can say that our language can be either a finite language or it can be an infinite language. Now let's see an example. Now if I say my language L1 is the set of all strings of length 2. That means what are all the strings that I can form with only length 2, and what is my sigma here going to be? My sigma is going to be sigma is equal to a comma b. So over the alphabet, sigma is equal to a comma b. I want to form set of strings of length 2, and that is going to be my language. So what are the strings that we can form? We can form a, then we can form BB, then I can form AB, then I can form BA. So I can form only 4 strings, right, from this alphabet. So the number of strings that I can form is finite. Hence, the language is called as finite language. Now look at the next example. Now my L2 says set of all strings that starts with A. Over the same alphabet, sigma is equal to a comma b. Now what are all the strings that can start with A? It can be A, AA, AB, ABA. Right here, AAB. It can go on because there is no restriction on the length of the string. I just said set of all strings that start with A. So the number of strings that can be formed here is not finite. I can form any number of strings that belong to this language. Hence, this language is called as an infinite language. So I hope this video was very clear for the introduction to theory of automata and the basic terminologies that we use in the theory of automata. Thank you.